Okay, if anybody is here that hasn't been here before, my name is Dustin, and I am a web developer, a programmer, and a teacher. And um, I to get into this career field, I went through boot camp, very similar to Lambda's. And it was a successful career switch, and I've been doing this kind of work ever since then. I also had the opportunity to teach at that boot camp for a few years, and decided to look into Lambda because of the awesome curriculum and the business model. I like what Lambda does with being able to reach a lot more students because of the pricing model. So if you haven't seen or heard before, the pricing with Lambda is different than most boot camps that you could go to learn programming. The biggest difference is if you don't have to pay for this class up front, like pretty much every other one out there. Lambda takes on the risk of paying that money, and you go through the class, and after you graduate, you don't start paying that the tuition back until you have actually been hired and start working as a programmer. So it's a really fantastic business model, and a really great way that we can reach a lot more people than could generally be able to take this class. Excuse me. So I really like what they're doing there. I love the people that are associated with Lambda that are writing the curriculum. They're some of the smartest, brightest people that are in the industry today. So you know that with this program, you're going to have a lot of opportunity to be successful through here. So, all right, today is our second to last class, and we're going to be talking about classes, JavaScript classes. Let me jump on here and share my screen. And jump here to Chrome. Okay, we can get rid of that. Let's ban this one. So JavaScript classes they're pretty neat. It's a little bit more complicated than anything we've seen so far, but that's kind of been the trend. Each day we're kind of building on something that we've learned before. So on Tuesday, we learned about arrays and objects. And we learned that we can group a set of data that are all associated with the same thing in an object. Something like this, right? So we've got an object that's got properties and values, et cetera, et cetera. So let's look at a class and see why we need a class to help us extend this functionality out even a lot more. So a class is actually not technically a class. Kind of confusing, but that's in the classical sense. So if you come from a object-oriented programming language like Java or something like that, then you have an idea of what a class is. A JavaScript class is different than those classes that are kind of the classical object-oriented languages. In JavaScript, we have this idea of classes that's basically a special function that's built to somewhat simulate those classical classes. So why do we have this? Why do we have classes? They give us, a class in JavaScript gives us added functionality with this idea of constructors. Again, if you have a background in some of these other programming languages that have real classes, you'll know what a constructor is. So with JavaScript classes, we get access to a constructor as well. So what is a constructor? Well, the constructor method, so constructor is a method on our function, on these special class functions. The constructor method is a special method for creating and initializing an object created within a class. So let's break this down kind of one line at a time as we look at the syntax of a constructor. So let's say we are building, let's say, characters. We're going to have a function built out like this. Now notice we did something different here than we've done before with our syntax. So the name of this class is actually capitalized. Everything else we've done before, we've named the variable or the function or the whatever it is, the variable name has been lowercase. With classes, since we don't have the traditional class, we need a way for other developers to know and understand that what we're building here is not just a normal function, but it's actually a class. And the way we do that is by capitalizing the variable name. Now you don't have to. Syntactically, this will work, but we always, when it's a class, we always capitalize the name. All right, so we know that a class is a special function, so we've built out this function. Now, we've got this idea of creating and initializing an object. So what does that mean? Well, let's look at an example real quick. Let's do something like const Yoshi equals, let's say, so let's build out a Yoshi object in the context of Mario Kart. So if you don't know, Mario Kart is a Nintendo game, and it's basically just a racing game with some of Nintendo's famous characters like Mario, Luigi, and Yoshi, and some others. So that context should give you an idea of what we're doing here. So we'll say Yoshi's speed is a 9 of 10, and we'll say his strength is not quite as much as some others. We'll say a 6, and let's say we're keeping track of how many wins these characters have. Yoshi has 0. And then let's build a function called addWin, or a method on this object called addWin. All it's going to do is do this dot wins plus plus. So it's just going to increment wins by 1 whenever we call this function. Okay, let's do Mario. Build a new object. Mario has a speed of 8 and strength of 7. Everybody's going to start with 0 wins. We're just starting our Mario Kart tournament. For those of you who are not teenagers, you'll probably remember LAN parties and getting together with lots of different computer screens or TV screens and playing in tournaments. That was kind of my inspiration for this example today, was doing that. Let's go Bowser. Okay, Bowser's speed is lacking, but where he lacks in speed, he definitely makes up for it in strength. Actually, let's take a look at this. So what are we doing here? We're kind of building out the same thing for every character. So I can basically just go like this. Copy, paste, and just fill in the correct values here. So this is a problem, right? This is kind of going against our idea of being dry, right? Which means don't repeat yourself. Well, we've kind of repeated ourselves over and over and over again here. What if there's a way, what if there's a special function that we could write that would create all of these for us? Dun, ta-da. Hey, we have special functions in JavaScript called classes that create and initialize objects. Well, that's exactly what we need to do. We need to create and initialize each one of these objects right here. So let's see what that would look like if we did that with a class. But we're going to do this real quick, just so we can use those variable names again. Okay. So we're going to create a class called characters, and characters is going to create these objects. And what we're going to do is we're going to say that each of these properties is going to be added to this object. So a class creates an object called this and returns it auto-magically to where the class is called, okay, where the class is invoked, called invoked. So when we create a class, we automatically have this object created for us. And the way that we add these properties that we would want if we were building things out this way is by adding these properties to the this keyword. Ooh. Just like this. This time, add wins, add win. Okay. Now we haven't given these values yet because we're not quite there yet. All right, so we've got two variables that are the exact same for all of these, or their value. Let me start that sentence again. We've got two properties in all of these objects that are the exact same. Wins and add wins. On all of these, they all start out with 0 wins, And the add win function is the exact same. But let's take away that, oh, not that much. Let's take away that extra s. There we go. So down here, we can give these properties the same value as we have up here. But you'll notice that speed and strength in all of these objects have different values for each different character. So we need to pass those in as, we'll define these as parameters in our special function, in our class, speed and strength. And then we'll reference these in the value to set the value of the properties in our constructor, or excuse me, in our class. So let's take a look at this. We've got a class now created that looks very similar to these objects, except that it's a function, right? So let's look at what's going on. A class, we know that a class creates this object, and it's going to be returned to wherever we call this function. And on this object, we have properties that matches the properties that we are looking for in these objects up here. Then, don't get confused by these being the same name here, because this dot speed refers to a property on this object, and speed out here, the value of this dot speed is referring to the parameter. So whatever gets passed into this function as the first argument will be the value of this dot speed. And whatever gets passed in as the second argument when we invoke this function will get passed in as the value of this dot strength. So let's see what this looks like down here under the new keyword section. When we invoke a class function, we need to use this keyword, or the new keyword. So let's create a new Yoshi object, variable name here, and we're going to use the new keyword, and let's say we're going to create a new character, and we need to pass it two arguments, speed and strength. So Yoshi's speed was 9, but this strength was only 6. And let's run that. Uh-oh. Up in line 34. Missed a semicolon right there. Okay. I missed more. Yep, down here because we just copied and pasted code. That's the problem when you copy and paste code. Oh, character is not defined. We're missing the S right there. So let's try that again. Okay, perfect. And let's look at Yoshi, our new Yoshi object. There we go. We've got an object with a speed, strength, wins, and add win function. What happens when we use our add win? Let's say we're at our LAN party and Yoshi character wins. Whoever's playing Yoshi gets the first win. We invoke that. After we've created a new Yoshi character, we invoke his add win. And you can see that he now has 1 win. So this is working perfect. It's the exact same as if we had gone up here and used our not dry Yoshi, add win, and then looked at that. that same thing. We got, oh, let's console log this. It's looking at the one that, the line of code that's at the very bottom. There we go, speed, strength, one win, and a function called addWin. So our Yoshi down here that was created and instantiated with this class looks the exact same as the Yoshi that is up here, that's created in the non-dry fashion. Obviously, we want to stay dry, and we like the functionality that this class is giving us, so we're going to stick with what's going on down here. And I'm going to quit these because it's making my computer heat up pretty quickly. All this real-time chat stuff. Okay. So let's do the same thing. Let's create a Mario. Oh, lowercase new, capital characters. And Mario was, what was his speed? 8, strength 7. And let's create a Bowser. Now notice that I'm not making these, I'm not capitalizing these variables here. The reason for that is these are capturing what characters is creating. They're capturing the object that characters is creating, but they're not actually classes themselves. This is the class, this is the character's class. These are actually just objects that we see right here. So we keep those lowercase. Now if we look at Mario, we see Mario, the Mario object here. If we look at Bowser, let's copy Mario real quick. We see Bowser, there is his, right there. Okay, so we just found a really cool way to create a whole bunch of objects that look exactly the same without writing them every single time. Imagine if this was an object that had 12 or 15 properties and was 3 times as long as one of these objects here. It would definitely get tedious to do that over and over and over again, right? So let's bring our Yoshi down here. And give you the output there. Now, there's a couple things with classes that we need to talk about. Some proper ways to do things and some potential problems that we could run into. So that starts with this keyword. So this keyword in regards to a class can get pretty confusing and sometimes do some things that you don't think that it's going to do, or it will sometimes refer to something that you don't think it's supposed to refer to. So you'll notice that inside our characters function, or class, we've got this addWin function, and it's using this keyword to reference a property called wins. And then it's going to increment that property. Now, we invoke this function that's using this keyword right here, right? So we've got our object that was created in this class. We've got our object and our method. With this keyword, the context of this can be different than you think. So there's a pretty straightforward way to kind of understand what the context is, and that is by looking to the left of the period when the method was called. So the method is add when, and down here we invoked it. So this is where add when is being called. What is to the left of the dot? The left of the dot is Yoshi, which is was created by our characters class. So this let's bring this down here. We're going to copy this. This in add when is going to refer to the characters class, more to the object created by the characters class. And we'll give this a name, Yoshi. Okay, so when we invoke add when, and it goes up here, and it looks at this, the computer is going to say, okay, what is the context of this? So it knows where to perform this, or how to evaluate this JavaScript expression. So it's going to go back to here, to where it's invoked, and it's going to look at to the left of the period when it was invoked, and it's going to say, and that's what this up here is going to refer to. So this in add when, this one right here, this in add when is going to refer to the object Yoshi, which was created by our characters class. So Yoshi, if we remember what Yoshi looks like, Yoshi has these properties. And so this is this object right here. And this dot wins is this property with a number value. So every time we invoke add when, every time we run yoshi.addWhen, it knows to look at this object and to increment this number here. Now, it seems obvious right now, but there are quite a few cases where the context of this actually gets not lost, but is something different than what we think it is, and what we think it should be. And so we get a little bit lost saying, why is this not being incremented? This function is supposed to do something and it's not happening. If it's inside a constructor and you're using this keyword inside a method, you just need to make sure that you are doing everything syntactically correct, that you're using the correct syntax and invoking it the correct way, because the context, you need to make sure that the context of this is what you think it is. All right, if that sounds confusing, that's because it is, and it's probably one of the tougher things that you'll learn as a JavaScript developer. In fact, let's just do a quick Google search here, and you'll see what I'm talking about. Understand JavaScript's this with clarity. Understanding the this keyword. Understanding the this keyword. JavaScript this keyword, how it works. A gentle explanation of this keyword in JavaScript. So just the fact that there's 7 blog posts in a row trying to explain to you how the this keyword works means that so many people have gotten on here and looked for it and have found that and think that they can do a better job explaining it to developers, that they get on and write their own blog posts. And if you were to continue in here, you'd see that there's a whole lot more than just these 7. There's usually some pretty good images associated with this. Let's see. Oh, that's not. Okay. That's okay. We'll move on. There's definitely been some good memes and different things put out there concerning the this keyword in JavaScript. So I just want you to be aware, we're not going to go through every case that this could be, give us the wrong context, but I want you to be aware of it in case something's not working the way you think it is. It might have to do with the this keyword. In this example, it's pretty straightforward. So this is kind of a hard example to use to explain the complexity of it. So hopefully this is pretty understandable here. So we're going to pause talking about classes for just a minute, and I'm going to throw kind of a bombshell at you guys. In JavaScript, dun, 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 everything is an object. Well, what do you mean everything? Arrays are objects. Strings are objects. Numbers are even objects, etc., etc. Everything. Oh, meant to Command C that. Everything is an object. This is not a lie. I am not joking. I'm not trying to pull a trick on you. In JavaScript, everything is an object. Now, I want to bring up this bombshell, this secret truth, because I want you to see the context of everything that we're talking about, that we've talked about so far, and today with classes and constructors and methods. And I think this will help everything kind of come around full circle and give you kind of a better, higher view understanding of JavaScript. So let's take a string. There's a game, since we're on our Mario Kart binge today. Okay, we've got a string, and on our string we've got a property called length, correct? Right there. This string is 9 characters long. Let me take away this console.log real quick. Okay, there we go. So if you look at this syntax, what does this look like? An object. We have a variable name that's set to a string, and it has a property on it. Just like our Yoshi object has a speed property, right? Whereas if we were to do that, Yoshi, let's do strength so they're not the same. Here, there we go. We have a variable and a property. A variable and a property. When we look at things in JavaScript that are not objects, even though everything is an object, if we look at arrays or strings or numbers, they're all objects, but they're special objects. They're set up specially so that they can have properties and even different methods like this. Mario Kart, everything's uppercased now in Mario Kart. So our string object has properties and methods. Just like writing a literal object, if we were to do const sum object, has properties we'll just give it a random value of 0 and methods. Methods. There we go. Right? So string being a object has the same thing. But what if we just, let's console log game here. Actually, let's first console log Yoshi. When we do that, we see this object, right? We see the properties, we see the method built onto this object. But what happens if we console log game? What if we console log a string? Well, all it does is give us this string. We don't see length. We don't see to uppercase, right? Why is that? That is happening because, I guess we can move all this back up since it kind of fits in the flow here. So this is happening because of the object prototype, where this property and this method are actually not built on this exact string. They're built on the prototype of this string. And with it, the prototype is kind of a higher level object that this string is inheriting certain properties and methods from, like length and to uppercase. So the other day when we were talking about strings, we went to MDM and we looked up this string to look at its properties and methods, right? I don't know if you remember this. We need to, let's just say JavaScript string. Oh, I think it was arrays. Do. For some reason, my internet is going very slow right now. Don't know why that is. Okay, we looked at properties and methods, and we kind of skipped quickly past the properties because it mentioned array.prototype. And I didn't want to talk about that at that time because it didn't make sense to teach about those until we talked about classes. So arrays, all these special types of objects have prototypes, and that's the same for our classes. So what is a prototype, and why do we care about them? So a prototype, a property or a method, as we've seen, do not actually show up on when we console log or when we look at our objects, but yet somehow they're still magically there because we're still getting values from running this expression, right? So a prototype extends the constructor with functionality. And then that functionality will be available to all the object instances that we create with the new keyword. I don't know what that is there for. So let's break that down a little bit. A prototype extends the constructor with functionality, something like returning the length of a string. And then on any object instance that's created with the new keyword, they have access to that functionality. So in JavaScript, in the language itself, the code that sits in your computer, they have defined a constructor called string, or excuse me, a class called string, and it's a function and it will do some things, right? Like create a string. And then on this string prototype, so let's say we do game, when you instantiate a new object with the new keyword, like this. So that's what this means. We're instantiating a new object with the new keyword. And let's just say that this somehow outputs a string called Mario Kart. So if this somehow, let's do game 2. If this somehow output a string called Mario Kart, then JavaScript under the hood would do this. It would create a new function called length on the prototype of our new object. So all of our objects, whether they're strings or arrays or actual literal objects, all have this prototype thing where we can define new properties or methods. and then this would somehow, no, somehow output the length. Okay, if we actually wrote the functionality of this. So this is kind of what the prototype is looking like. Every time that you define a new variable and and give it a value of a string, it's instantiating a new object with the string constructor, as it's showing right down here. So let's look at this with the example of our Mario Kart game and our characters class. Speaking of gaming, my computer is being very laggy right now. Let me see if we can refresh this page. Okay, a little bit closer. Oh, now we're refreshing. Sorry about that. Let's see if this works a little better. This is really struggling right now. Okay, that feels a little bit more fluid. There we go. Let's just get rid of some of these. And are there any other windows? Nope. I'm going to close Slack and force close my editor. That takes up a lot of RAM. All right, that should be a little smoother. Computers. Okay, we're gonna just comment all of those out. Okay, so let's look at our Yoshi. Actually, we're going to go back up here and look at our characters. So one thing that we learned in the JavaScript world is that when we declare a function, whether it's a method on a project or an object, or I started reading property, whether it's a method on an object or it's inside a class, like this is, or if it's just its own variable out here. We found that performance-wise, on your computer's memory, this is actually what we refer to as an expensive thing to do, meaning it takes a lot of your computing power or your RAM in your computer to do this. So declaring functions is expensive. So we came up with a trick that, let's pretend that we wanted to build out, we want to create 100 of these characters. All 100 of these characters would have their own instance of this function here. And it would take a lot of computing power for your computer to do this. Actually, technically 100 wouldn't be bad at all. But let's say that we had a class that had 15 functions on it, 15 methods on it, and that class had to, or we had to create thousands of objects from that class So now there were tens of thousands of instances of this function. Well, when that's the case, then we really start to run into problems, especially if the end user of your product has a really old computer or just a cheaper computer that doesn't have very much computing power behind it. So instead of declaring functions here in our classes, we're going to declare a function on the prototype. So we're going to say characters.prototype add when equals. Now if we look up here, I actually did this wrong. This should be string. There we go. And then we're just going to steal, actually we can completely delete this off of our characters class, because we're giving it, we're gonna declare add wins on, or add win on its prototype instead of inside the class itself. Now what this does is it gives this function, it only declares this function one time, and it lets every single instance of our character class, so it lets Yoshi, Mario, and Bowser all refer to add win from the prototype. They don't have their own add win. We're going to run into problems here and here because it's not defined until way down there. So now when we do Mario.addWin, and then look at Mario, we see that Mario has one win. But if we look at, when we look at Mario, we don't actually see the add win method on the object. That's because it's not on the object. It's now on the prototype of characters. So even if we had tens of thousands of objects created from characters, there's still only one instance of this function created in the computer memory, and that's right here on the prototype. Now, as I said before, the prototype is kind of a higher level object that these objects can inherit the properties and methods that are attached to that prototype. So prototype is sitting up here, and it's got this addWin method on it. And so Mario, since Mario was instantiated with the characters class, can look at the reference of characters.prototype and find addWin in order to run that function. And what's so cool about this prototype idea is that we don't lose the context of this. So we notice that we're using this inside this method still, right? And it's doing the correct thing. It's adding a win for Mario. It didn't add a win for Yoshi. If we look at Yoshi, Yoshi has 0 wins now. If we look at Bowser, Bowser has 0 wins. So this whole system is smart enough to know to point to the correct things when we use the this keyword. It knows that it's being invoked here, and it's going to look to the left of the period and find the correct object and add a win to that object, but not to any other objects. We could have a list of 100 million objects that had all been instantiated from characters and just run mario.addWin, and all 900 99,999,999 other objects would have 0 wins. Only Mario would have our 1 win. So this is what makes it a little bit different than your typical object-oriented languages, where they have they inherit or just your typical inheritance with those languages is different than the inheritance model with JavaScript. That point of knowledge is mostly for people who are coming from a background of other object-oriented languages, not for if this is your first intro to programming, don't even worry about what I just said there. Okay, let's look at everything that we've talked about today. So we talked about classes and what they are. They're just a special function, and that gives us added functionality to our functions through constructors, which is a method, a special method. So we've got a special method built onto a special function for creating and initializing an object created within a class. So what that means is these properties are the properties that will get added to a object when we use the new keyword to instantiate a new character. And instead of adding something like this, with classes, instead of adding functions or methods on here, we're going to put them onto the character's prototype so that there's only one instance of this function, of this method, built into our computer memory system, because declaring functions is expensive. It takes a lot of computing power, more than any other type in JavaScript. So we only want to do that one time, but by adding it to our prototype on characters, we've now given the ability for every single object that's created by characters, that's initialized and created by characters, the ability to point to add win. They all inherit that function through the prototype. So they all have the ability to reference and run function within the correct context of that object. So there we go. Pretty high level overview of classes. Okay. Again, we'll get homework out to you, and please, if you have any questions, reach out to us. I can't go through the Q&A today, so I apologize for that. Adam's been on there answering questions for you. I have to take off right now, but yeah, great class, lot to learn. We've got one more class tomorrow, and then we'll be done. So thank you so much for being a part of this class. And please stay in the Slack channel, whether or not coming to Lambda to our evening time classes. Hang out in Slack so you can keep learning things, and watch what other people are asking so you can learn those things yourselves. When you have questions, direct messaging back and forth with quite a few of you. I'm happy to answer questions and help out however I can. And yeah, I will see you tomorrow, same time, for our last and final class. Thanks.